All right, guys. Tyler, let's put that away. What we're talking about today, what we're starting with is Chapter 8. So today we're starting Chapter 8, and Chapter 8 is going to cover similarity. We're talking about similar figures. So the shapes will be the same, but one is either going to be bigger or smaller than the other, and we're going to be talking about how we can kind of find different lengths or different properties of similar figures. Now, if two figures are similar, they're really just going to be one is going to be bigger or smaller than the other. We're going to have a scale factor. We're going to either be scaling it up or scaling it down, depending on which direction we're going. Now, one of the key things for two figures being similar is that their corresponding angles are going to be congruent. The corresponding angles between similar figures will always be congruent. They're always going to be the same. Their side lengths are going to be proportional. Corresponding side lengths are proportional, and that's our scale factor. Now, the scale factor, this scale factor K, is going to be greater than 1 if the shape is getting bigger, if we're going from smaller to bigger. And the scale factor is going to be less than 1 if we're going from a bigger figure to a smaller figure. And that's the main thing we're going to be talking about today, is talking about these scale factors and corresponding proportional sides, these corresponding sides, and the congruent angles. Now, when we look at these two figures here, in the diagram, RST is similar to XYZ. This little squiggle line between these here is saying that these two figures are similar. Because we use an equal sign if we're saying that they're equal, but these two are not. They are just similar. One is bigger than the other. Because if we look at the two triangles, well, RST has side lengths of 25, 30, and 20. XYZ has side lengths 15, 18, and 12. RST is obviously a bigger figure. It has bigger side lengths. Now, we can look at scale factor in a minute. We're going to look at the congruent angles first. Because this here, these two similarity statements actually tell us which angles are congruent. Because it listed which angle first for RST. Angle R. Which one did it list first for XYZ? X. So angle R is actually congruent to angle X. So for part B, we can say angle R is actually congruent to angle X. So it went from R to S. So which angle would be congruent to angle S? Well, lastly, we have T, and it would be congruent to So we have the corresponding angles, or not corresponding, but the congruent angles. We can see which angles are congruent to each other, yes? Now the corresponding sides are going to match up. Now when we have all three sides, well, it's going to work out that the biggest is attached to the biggest, smallest to smallest, medium to medium. So looking at this here, I'll get a highlighter out. So RS, is that the smallest, biggest, or kind of side length in the middle? So 25, 30, and 20, 20 is the smallest, yes? So if I look at the other figure, which side is the smallest? So RS and XY would match up. If we look at the angles, angle R has our angle with 1 mark, and it goes to the angle with 2, yes? Did we highlight the side of the other triangle that went from 1 to 2? Yeah, so we can use the angles or the side lengths to match them up. So if we look at TR, so we're going from 1 to 3, or 25 is between 20 and 30, it's the middle. Now look at the other triangle. we'd look at ZX because it does match up with the angles, and well, 15 is between 18 and 12. And the last one is our TS, which would match up with our ZY. Now that we kind of have these set up, are there any questions on how the side lengths match up or compare to each other? Now the proportionality statement is just 3 fractions. And what we'll be using is the side lengths. We're going to be using the side lengths here. So we started out with RS. So we can put it on top. And we said what side matched up with RS? So we put XY on bottom. Now the one that we put on top, the side lengths we put on top and the side lengths we put on bottom really don't matter which one we do until after I do the first one. Because I chose to put RS on top, yes? That means the other two that are on top have to be side lengths from triangle RST. Because we need the same side lengths connected to the same triangle all on top. So since we chose RS, well, the other two are going to be ST and TR. Now we could have chose TS or ST, either one works, or TR or RT, because again, flipping those doesn't change anything. Now, which side length did ST connect to or match up to? ZY. So it goes on bottom. And TR connected with ZX or XZ. Either one works. And that's our proportionality statement. Any questions on any of this here? So, okay, that took care of B and C. And I find finding those first makes a little more sense. So when we go to the scale factor, we know what we're comparing, what we're matching up. Now, it wants us to find the scale factor from RST to XYZ. So we're going from RST to XYZ, yes? Are the sides going from bigger to smaller or smaller to bigger? Bigger to smaller, because we're going from 25 to 15, or 20 to 12, or 30 to 18, any of these here, yes? So our scale factor, should it be greater than 1 or less than 1? Because where are we going? We're going from bigger to smaller, yes? So we should expect it to get smaller. So the scale factor is actually less than 1. If we're getting bigger, it should be greater than 1. Because what we're saying is that if I multiply 25 by the scale factor, I should get what? 15. It should get smaller. Now, a way to remember how to do this, especially finding the scale factor, what they'll call K, and we'll call K, is I say new over old. What are we going to over what we came from? What we're going to where we came from. K. We say scale factors are K. Now, so all of these here, 25, 30, and 20 are kind of the old. That's where we're starting from, yes? So pick one of those for our old values. 20. And it would go on bottom because that's where we're coming from. Where are we going to? So to get the scale factor, we do 12 over 20 because we're going to 12. We came from 20. Now at this point here, we could actually type this into the calculator. Clear. 12 over 20. And we get, so the scale factor is, well, it worked that way for this one because we were going from bigger to smaller. If we were going the other direction, we would have the bigger number on top. So this is A, yes. Yes. Any other questions over this first one here? All right, we'll look at the next one. And this next one is the exact same thing as what we just did. We're going to find the scale factor, our congruent angles, and the proportional side length, statement of proportionality for the side lengths. So we'll find A in a minute, because finding the scale factor is really a little bit easier if we know which side lengths work together, which ones are proportional. I think out of all three, it's a little bit easier to find the angles first, isn't it? Because it's just based off of what? Our beginning statement. So it starts out saying ABC is similar to JKL. Well, we'd have A and J. Both of them came first, because when we talk about similarity or congruency statements, they follow the same path. So B came second, and then K came second in the other, which leaves us with saying A is congruent to angle J. Angle B is congruent to angle K, and angle C is congruent to angle L. Any questions on part B before we look at part C? So we need a side length to start with, which would be AB or BA, yes. So we just kind of picked a side length to start with. Now, we can find the side that matches to this here, because BA, so we have the side length that goes from the angle with one marker to the angle with two, yes? So on the other figure, I would look for the side length that goes from the angle with one marker to the angle with two, yes? Or 27 is the middle side length, yes? It's between 36 and 21. So the middle side length on the other triangle would be 36, because it's between 28 and 48, so that would make those two match, which is really telling us that this here should be KJ. What's another side length? KJ or JK, either one. Yeah, either way works. I just put KJ. I have a tendency, yeah, I don't know why I put JK or KJ. So Logan, what would be another side length we can start with above? Yeah, because we'll need BC, and then we would need also AC, yeah. And that would, yes, because I went a different direction than you thought I was going. Because BC would match up exactly to KL. And well, the last one is JL or LJ, because that'd be the last set of sides that match up. Now, the last thing we need to find is the scale factor. Now we're going from ABC to JKL. So are we going from smaller to bigger or bigger to smaller? So we should expect the scale factor to be greater than 1. Because if we're going to make something bigger, we need to multiply it by a number bigger than 1. So new over old. Now again, it's good to simplify the scale factor down if we can. This actually reduces to 4/3. And no matter which one we pick, because if we depict 36 over 27, we'd get it 4 over 3. If we had to pick the last one, 28 over 21, we would still get 4 over 3. Because the scale factor, as long as we pick the corresponding sides, will give us the same value. Well, we actually already said that would be the case. Because we said those corresponding lengths, when we divide their amounts, will be the exact same thing. And that's it. Questions on this here? Last one that we'll look at doing this here, where we're rewriting the corresponding parts with these proportional fraction and our corresponding angles. So we'll still look at the scale factor, congruent angles, and our three proportions. Now for this here, they're telling us JKL is congruent, or similar, not congruent, similar to PQR. So angle J and angle P are congruent. Angle K and Q, and then R and L. And that's all we've got to do is write that in for part B, is saying that angle J is congruent to angle P. Angle K is congruent to angle Q, and angle L is congruent to angle R. So all we had to do was use the statement, the beginning statement, and we could write these here. Now, what's one of the side lengths we can use for our proportionality statement? JL. And what side length corresponds to it? PR. How about the next one? JK. And lastly, exactly. Now the only thing we're missing is the scale factor, yes? So if I want to find the scale factor, well, we can use two of the side lengths, two of the corresponding side lengths. Which one do we want to use? Well, we can say 4 over 6, which reduces to 2 over 3, yes? And that would be it. And again, because again, I scrolled up just to make sure where we're going. JKL to PQR, so it would be 4 over 6, which would give us a scale factor of 2/3. Questions on this here? Not too bad. Because really, if we took this scale factor and said 6 times 2/3, well, 6 times 2 is 12. And 12 divided by 3 is 4. Well, that's not right, is it? No. So let's look back at the scale factor. So we said 4 over 6, yes? So where are we going? From 4 to, is it getting bigger or smaller? Exactly. Which would be 3 over 2. Okay. So let's try this again and see if we get the correct amount. Now this time 6 times 3 is 18. And 18 divided by 2 is? Which is what we wanted, yes? Because the 6 connected to the 9. Now, if I did the same thing with 8, what number do we want to get? 12. Now, 8 times 3 is 24. And 24 divided by 2 is? So we get the exact same thing that we're supposed to get. Now, 2/3 would work if we were going from PQR to JKL, if we're going the other direction. Okay. If there are no other questions on that there, we'll look at the core concept, this next core concept. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of the similar polygon. That right there. That's all it's saying. If I have two similar polygons, well, we're told that these two are similar, yes? Then the scale of 15 to 18 is going to be the same as x to 30. And I can use that scale to find any length, as long as I know what the scale is. So really with these here, we're looking at a proportion. We're looking at two fractions that are equal. Personally, I always like to keep whatever I'm trying to solve for in the numerator. So we're trying to solve for what? X. Okay, I'm going to put it in the numerator. What side length corresponds to this? 30. Well, we know it mainly because of the statement given. It is good to pay attention to that because they might throw it so that it's not necessarily lined up the exact same way. But DEF, DEMN, these two sides match up, which does make our NP and EF be the same. So it does work out that way. Now, any questions on this here so far? I'm still missing two numbers, yes? So whatever number we put up in the numerator has to be from which triangle? The first one, because we put x on top, I need a side length from the same triangle. So we can use 20 or 15. Do we have the side that corresponds with 20? Yes. Do we have the side that corresponds with 15? Yeah, so we just need to pick one. We can say 20. And it's going to be over. So if we pick 20 over 24, it's still going to give us the same answer as if we picked 15 over 18, because we know the scale, these will all reduce to the same amount. Now the only thing we have to do at this point is get the variable x by itself. And to do that, we're going to multiply both sides by 30. I'm going to write this out for the first two just so we can see it. Because if I multiply x over 30 by 30, this 30 multiplies with the numerator. So they tell us that we have 30x divided by 30 is equal to 30 times 20. Well, we have two zeros, yes? 3 times 2 is? So 30 times 20 is 600. And this is going to be over 24. Now on the left-hand side, we have 30x divided by 30. Well, apparently I'm going to erase. Because we have this here, yes, 30 divided by 30. Anything divided by itself is 1. So 30 divided by 30 is 1, which is really leaving us with 1 times x, which is the same thing as x. Now the only thing we need to simplify is 600 divided by 24. We could type that into the calculator and it would give us an answer. That's it. Yeah. Now we said that NP was the side that it corresponded to, yes? Is NP the smallest, middle, or biggest side? Biggest, yes? So that tells me the side length I'm finding should be the biggest, yes? If this side length is 25, is it the biggest? Okay, yeah, that's the right answer. So knowing about that property of similarity, we can make sure, did we get the correct answer? So if I had gotten a value that was smaller than 20 or 15 for this one here, we knew it can't be right, that's wrong. Because that value should be the biggest since it was matching up to the biggest. All right. We'll do another one. In the diagram, triangle GHM is similar to triangle HKL. Find the value of x. Yes. Now, we're wanting to find x, yes? Which side lengths does it correspond to? So, you can use a highlighter here. So I have that GH corresponds to HK. We have that KL, so GH and then HM and KL. And lastly, KL, HL, and GM. So looking at this here, X responds to now we need another two lengths, yes? So we put X on top, which was connected with this triangle here, yes? So the other length on top has to be connected to. So what are, we have 15 and we just have to pick one. Because we pick 15, it's going to be over 10. Now what do we do next? We multiply both sides by 12. And we do this because these will cancel out. They will simplify to 1. Because we're saying 12 times 1/12, which is 12/12, which is 1. Yes. We could plug this side into the calculator, and it would give us an answer, which is and that's it. Any questions on this here? We're going to look at two more of these, this one and the next one, and then we are going to stop there for today, and we'll pick this up tomorrow. Now, again, just like with the last one, we want to find the altitude for this here, and the altitude is the length or the height of the triangle. It's the length that connects a vertice to the opposite side and forms a right angle with the opposite side. So we want to find that length, which is x. And what would its corresponding side length be? 20, because we'd have x over 20 is equal to what over what? 6 over 8. Now what do we do? Multiply both sides by 20 because we want to get the variable by itself. Now multiplying the left side x over 20 by 20 will get us x by itself. Now we need to multiply 6 over 8 by 20. which we can do in the calculator, which would give us what? 15? And that's it. Any questions on this here? So we want to find the median. And a median for a triangle is a segment that connects a vertex, the angle, to the midpoint of the other side. So we want to find that length there, which is our x. And it's going to be over what? 12, because that's the side that matches up to it in the other figure. It's going to equal what? Match up our 36 and 16. Now our next step is to multiply both sides by 12. Here the 12 and 12 would telling us x is equal to 36 over 16. 36 over 16 times that's it. Any questions on this here? You kind of like this so far? Yeah. So this is where we'll pick up for tomorrow, but I think most of y'all might be able to do this one here. Because where are we going for this here? From 6 to, from 5 to 10, so 4, 2. It's nice when we have nice